So we're going to continue with some examples. We'll do number 6. So looking at number 6, is it set equal to 0? No. So we need to subtract the 4x squared from both sides. And we get 8x to the 5th plus 1x squared, or plus x squared, equals 0. Do we have a GCF? Yep, x squared. Leaving us with 8x cubed plus 1. Look at your factors. Do we have a difference of squares or a sum or difference of cubes? We have a sum of cubes. So it is plus, so sum. 8 is a perfect cube, x cubed is a perfect cube, and 1 is a perfect cube. So this factors down. And we'll actually, if you want, because we'll need more room for this, we can skip this question and make it go in both boxes. So on this one, we're going to factor using sum of cubes. What is your A? It's 2x. The cube root of 8 is 2, and the cube root of x cubed is x. What is your B? 1. The cube root of 1 is 1. So then what is your A squared? 4x squared. Good. So 2x times 2x is 4x squared. AB, 2x times 1 is just 2x. And B squared, 1 squared is 1. So we have this x squared. And then your sum of cubes starts out A plus B. 2x plus 1. And then it's A squared. Your next sign is the opposite. So minus 2x. Your last sign is always a plus. Plus 1. What's left here in parentheses, this is not a difference of squares or a sum or difference of cubes. And this one will never be able to factor down. So we're ready to set each one equal to 0. So the first one, x squared equals 0. If you take the square root of 0, what do you get? 0. So x equals 0. 2x plus 1 equals 0. So we're doing setting each factor equal to 0. And we get 2x equals negative 1. And then dividing by 2, x equals negative 1/2. And then this other one, how are we going to get the x-intercept on that other one? Quadratic formula. We just filled in A, B, and C to your formula. My A was 4, B is -2, and C is 1. And when I type those numbers into my calculator, I get -12 under the square root. And we have 8 on the bottom. Now, since the square root of -12 is not going to break down nice, we need to split that apart. And we get the square root of -1, the square root of 4, and the square root of 3. What is the square root of -1? Square root of 4? And then the square root of 3. So the square root of -12 turns into 2i square root of 3 over 8. Does it simplify? Yep. I can divide all of those numbers by 2. So x equals, now this 1 in the front, you have to put that 1. It's 1 plus or minus. This one you don't have to put because there's a variable with it. But you can't just turn that into 0. Plus I radical 3 over 4. Shoot. Are there any questions? Oh, these are ugly problems. Let me see. Let's just go, I'll pick some out on the back here to do. Let's go to number 12. Is it set equal to 0?
Yeah.
Yes. Is there a GCF? 2x squared. So
I can't get the answer.
Thank you, Siri. All 3 of these numbers are divisible by 2, and they all have at least x squared. Leaving me with x to the 4th minus 5x squared minus 24. And then we are left with a trinomial here in the parentheses. Do I need to use the box method?
No.
No, because there's not a number in the front. So grab this 2x squared. What's going to go in the beginning of these two factors? X squared. We want two numbers that multiply to be -24 and add to be -5. Got those? -8 and +3. Good. And if you put the 3 first and then the -8, that's also okay. This one is a difference, but 8 is not a perfect square, and x squared is not a perfect cube, so it's neither. It's not difference of squares or difference of cubes. And this one is not a sum of cubes. So there's no other factoring to be done. We'll set each factor equal to 0. 2x squared equals 0. If I divide by 2, what do I get? 0. If I take the square root, what do I get? 0. So x equals 0. X squared minus 8 equals 0. If we add 8, we get x squared equals 8. Then what do I do? Take the square root, which means I'm going to have to break down the 8. What perfect square goes into 8? 4 and 2. Anytime that you take the square root on these problems, you have to put the plus or minus. So x equals plus or minus. This is 2. The square root of 4 is 2. And then the square root of 2 doesn't change. Questions on that? Then we have x squared plus 3 equals 0. If we subtract 3, we get x squared equals negative 3. And then we take the square root. Now this is negative, so I have to pull out that negative 1, leaving us with square root of 3. 3 is not a perfect square, and there are no perfect squares that go into 3. So we just leave it square root of 3. So x equals plus or minus. What is the square root of negative 1? I. Then we bring down the square root of 3. Okay. Let's do number 13. Is this set equal to 0? Nope. So you got to subtract 16 from both sides. Is there a GCF? No. And it's a trinomial. Are we going to have to use the box method? Yes, we are, because there is a number in the front. So we'll probably run out of room on this one, so we'll just cross out number 15 and you can go in that box. Next year I need to fix these notes to put more room. So the box method. The 3x to the fourth goes in this square, and the negative 16 goes down there. We want two numbers that multiply to be what? Negative 48. 3 times negative 16 is negative 48. And then we also want those two numbers to add to be negative 2. So what two numbers multiply to be negative 48 and add to be negative 2? 6 and negative 8. Now, along with those numbers, I have to put an x squared. Because really what we did was we took this negative 2x squared and we split it into two parts to make this work out. And so that's why I put the x squared with those. And now we're going to look at the GCF. So the GCF of 3x to the fourth and 6x squared is what? 3x squared. Good. And what about the GCF between negative 8x squared and negative 16? Negative 8. Negative 4 does go into both of them, but the greatest factor is negative 8. What about 3x to the fourth and negative 8x squared? X squared. And what about 6x squared and negative 16? 2. So what that means is that I have the factors 3x squared minus 8 and x squared plus 2. Do we have a difference of squares or a sum or difference of cubes? Is 3 a perfect square?
No.
Is 8 a perfect square? No, 8 is a perfect cube. But everything has to be a perfect square for it to be difference of squares. So 3 and 8, neither one are perfect squares. So we actually don't have any more. So that means that we're going to set each one equal to 0. If we add 8 to both sides, we get 3x squared equals 8. And then if we divide by 3, we get x squared equals 8 over 3. And then we take the square root. So, trying to decide. Generally, you don't just leave a fraction under a square root. And you don't, so this is also the same thing as the square root of 8 over the square root of 3. And really, you're also not supposed to leave a square root in the denominator. But that's a whole nother lesson. Did you all ever learn how to rationalize the denominator? You all ever learn that? Okay. I'm just gonna let you leave your answer as one of these two would be okay for now. At some point, we need to do a little lesson on that because that's something that you also need to know, but not today. All right, so you can leave it as the square root of 8/3 or Really, this would be square root of 4, square root of 2. This would be 2 square root of 2 over the square root of 3, really. You probably won't even see any like this on the test anyway. And then the other one, we have x squared plus 2 equals 0. If we subtract 2, we get x squared equals negative 2. And then we take the square root of both sides. So this one I have to take out the negative 1, leaving me with a positive 2. And that square root of 2, can't break that down at all. So we have x equals plus or minus I square root of 2. And this should have been plus or minus over here too. All right. Questions? I know some of these are kind of complicated. All right, number 16. We'll do this last question and then we'll stop. Is it set equal to 0? Yes. Is there a GCF? No. The only thing it could be would be a 2, but then you can't divide out a 2 on this one, so no GCF. How many terms is it? 4, which means we're going to do grouping. So we're looking at the GCF of each group. This one would be x squared, leaving us with 2x minus 3. And then what is the GCF of negative 32x and 48? Remember, use what you have in parentheses as your hint. This has to be a 2x minus 3. Almost. Negative 16. So this starts with a negative, so we have to put a negative 16 there. And negative 16 times 2 is negative 32. Negative 16 times negative 3 is positive 48. And so factored down, we have x squared minus 16, 2x minus 3. With grouping, remember you have your outside numbers and then your inside numbers. Do we have a difference of squares or a sum or difference of cubes? Difference of squares, right. This one's a pretty basic difference of squares problem. So if you know what that is in your head, that's fine. You don't need to write out a equals the square root. Does anybody know what this one factors into? X plus 4, x minus 4. Because remember, difference of squares is a plus b, a minus b. And 2x minus 3. Can any of these three be factored down anymore? This is, are you talking about the middle one? That it would have to be x squared minus 4. Yeah. If this was x squared minus 4, then yeah, it would be a difference of squares. So then we have x plus 4 equals 0. So what does x equal? Negative 4. X minus 4 equals 0. What does x equal? Positive 4. 2x minus 3 equals 0. Got to add 3 to both sides first. And then you divide by 2. To get 3/2. Any questions?